Okay, Wildcats, today we're looking at Friday, April 26th, composition of functions on page 78. So if you would, update your table of contents. Okay, now your table of contents are updated. Let's take a look at the notes. All right, composition of functions, page 78. Fog equals fg of x, and golf is equal to g of f of x. Little note, put one function inside of or in place of x is what composition of functions is. Okay, so if you would, update your notes. Now your notes are updated. Let's take a look at the examples. All right. Write each composition of function or composite function. State the domain and range. Okay. Given f of x equals 1 divided by 2 of x, and g of x equals x squared, and h of x equals x minus 8, and k of x equals the square root of x. Let me just lighten a little bit there. All right. Example 1. F g of x, okay, is equal to f of g of x, which is x squared. I don't know why I made that parentheses really big. Okay. So basically what we're doing is we're putting x squared into f of x. Okay. So that equals f, I should say, not f, right, and that equals 1 divided by x squared. So basically we took this x squared, and actually, I'm sorry, 2 of x squared. We put x squared in for x here, so that's 1 divided by 2 times x squared. Okay. Now, that in essence is done. I don't know why I put 2 equal signs. Okay. Now, at this point, we need to do the domain and range. Well, here we know that you can't have a number divided by 0. So what we need to do is set 2x squared equal to 0. Well, we divide by 2. So x squared equals 0. Take the square root of both sides. X equals 0. Okay? Or I should say, does not equal 0. Okay? So we know our domain then and range does not include an x is 0. When x is 0, we know that the y is undefined. So our domain is from negative infinity to 0 or 0 to infinity. And the range would be the same thing, negative infinity to 0 or 0 to infinity. All right, let's take a look at example 2. So g of f of I can't speak here. Let me try that again. G of f of x. So that's g of f of x is 1, and this is where I need the big parentheses, 1 divided by 2x. So we're going to put in 1 divided by 2 of x into g of x. So that's equal to 1 divided by 2x squared. Which, if you square, 1 squared is 1, 2x squared is 4x squared. Now, we again set 4x squared not equal to 0. Well, we know when you divide by 4, take the square root, we're going to know that x does not equal 0. Okay, then the domain and range. So negative infinity to 0 or 0 to infinity. And the same thing with range. So negative infinity to 0 or 0 to infinity. All right, now let's take a look at example 3. Okay, so then that's g of h of x. So h of x is x minus 8. So we're going to substitute x minus 8 into g. So then that's x minus 8 squared, which is x minus 8 times x minus 8. So before that, that's x squared minus 8x minus 8x plus 64. Okay, combine the negative 8 and the negative 8. So it's x squared minus 16x plus 64. Okay, so now let's look at the domain and range. Now we know a domain of quadratic is from negative infinity to positive infinity. Now the range, we know since this is positive, it's opening upwards. And we know that at this point right here is 64 is our vertex, so we know that it's bracket 64 to infinity. Okay, let's take a look at example 4. So that's f of k of x. So k of x is the square root of x. So you're substituting the square root of x into f of x. So that's 1 divided by 2 times the square root of x. Okay, now we need to rewrite that as 1 divided by 2 times x to the 1/2 All right, now you can't leave x to the 1/2 in the denominator, so we need to multiply this by x to the 1/2 divided by x to the 1/2, which we know is a special 1. So then that's x to the 1/2 times 1 is x to the 1/2 divided by, we now know that x to the 1/2 times x to the 1/2 is 1/2 plus 1/2 is 1, so that's divided by 2x. Okay, and so we rewrite that as the square root of x divided by 2x. Now, this normally the domain range would be from negative infinity to 0, 0 to infinity because of the x in the denominator, but we also know that the square root of x has to start at 0. You have to set the square root of x greater than or equal to 0. So we know that x has to be greater than or equal to 0. Okay, so the domain range would be, but also 0 is undefined because of here, so it's from 0 to infinity. And then the range is the same thing, 0 to infinity. So that's probably the most complicated domain range you'll probably ever see, with the square root in the numerator and an x in the denominator. All right, go ahead and finish up examples 1 through 4. All right, let's take a look at example 5. Find the value. So that's h g of 2. Now here we're going to actually include a number. So this is h of g of 2. So g of x is 2, so it's h of 2 squared, which is h of 4. So now you're going to substitute 4 where there's an x into h, so that's 4 minus 8, which equals negative 4. Okay, now let's take a look at example 6. So that's f of k of 4. So that's f of k of 4. So if we're plugging in 4 for x, so that's the square root of 4. But we know the square root of 4 is 2, so that's f of 2, which equals, now we're plugging 2 in for x, so that's 1 divided by 2 times 2, which is 1 divided by 4. But remember, the square root's plus or minus, so we have to do f of 2, and we also have to do f of negative 2. So that'd be 1 divided by 2 times negative 2, which equals negative 1, 4. Okay, so we're going to finish up example 5 and example 6. All right, now let's take a look at example 7 and 8. Write each composition function, state the domain and range. Now remember, the f of x and g of x have changed from the previous problems, okay? So now we're going to do f of g of x. So that's f of g of x, which is, this is where we need the big parentheses, 2 divided by x minus 1. Okay, so we're going to plug that in for x. So that's 5 times 2 divided by x minus 1 plus 2. So 5 times 2 is 10. Divided by x minus 1 plus 2. But here's the thing, we need to combine these so they have to have the same denominator. So technically this is 2 divided by 1. So what we need to do is multiply this times x minus 1 divided by x minus 1. And again, this is, remember, a special 1. Okay, and we can do that. But when we do it, they'll have the same denominator. So that equals 10 divided by x minus 1 plus, well, 2 times x is 2x times negative 1 is negative 2 divided by x minus 1. At this point, we're going to combine terms. So that's 2x, and then 10 minus 2 is plus 8 divided by x minus 1. Okay, now you always want to factor the numerator and denominator. So we can factor out a 2 here, which leaves x plus 4 divided by x minus 1. Now, domain and range. Okay. Now, we know that the x minus 1 we need to set equal to 0, so that's 1. So we know our domain is affected by the 1. So that's negative infinity to positive 1, or 1 to infinity. Okay, but we also know that there could be a horizontal slant asymptote, so we need to look here and use division. So we're going to take, and we'll do it here, x minus 1 divided into 2x plus 8. Well, you ask yourself, what do you multiply x by to give you 2x? The answer is 2. So we have a horizontal asymptote at y equals 2. So our range would be from negative infinity to positive 2, or 2 to infinity. All right, now let's take a look at example 8. So that's g of f of x. So that's g of f of x, which is 5x plus 2. So now we substitute 5x plus 2 in for the x. So that's 2 divided by 5x minus 2 minus 1, which equals 2 divided by 5x minus 3. Oh, wait a second. I'm sorry. That should be 5x plus 2. So 2 minus 1 is minus 1. Almost made a mistake. And actually, I'm sorry. 2 minus 1 is a plus 1. Almost made a second mistake. But nonetheless, I didn't. And so then it's 2 divided by 5x plus 1. All right, now let's take a look at the domain and range. So domain and range. So first off, we need to set the 5x plus 1 not equal to 0. So subtract 1, divide by 5, x equals negative 1/5. Or I should say x does not equal negative 1/5. So your domain is negative infinity to negative 1/5 or negative 1/5 to infinity. Okay? Now, the next thing is we need to look at the horizontal asymptote. So we need to, again, use division. So we're going to take 5x plus 1 divided into 0x plus 2. Well, yeah, so what do you multiply 5x to give you 0x? The answer is 0. So you have a horizontal asymptote at y equals 0. So your range would be negative infinity to 0 or 0 to infinity. All right, so go ahead and finish up example 7 and 8. And go ahead and start working on your assignment and have a wonderful Wildcat